Hey guys, so we've got number 9. The square root of 3 plus the tangent of 2x is equal to 0 on 0 and 2 pi. And we are not including 2 pi. Okay, so that's our interval. And I want you to see that we have a double angle, right? Whenever you see a double angle or a half angle, right? So something that looks like this, something that looks like this, in the argument of the trig function, you're going to let your u substitution be that argument. And whenever you're u substituting the argument, you are going to have to change the interval. You want to change the interval so that way this piece in the middle here matches your u substitution. In order to do that, I'm going to have to multiply each piece in the interval by 2. So now I have 0 is less than or equal to 2x is less than 4 pi. So now, yay, you can hear my son crying in the background. This is fabulous. Okay, so this is our new interval for the u substitution. I'm going to make him green also, just so you can see exactly what's happening here. Okay, so now I have the square root of 3 plus the tangent of u is equal to 0. And I'm just going to solve it. Okay, so I'm looking for where tangent has a trig ratio of rad 3. And it's going to be right here, rad 3. Pi over 3 is my reference angle. So I'm going to just write down a little pi over 3 over here so I can remember. Okay, and the sign of the trig ratio is negative. So I'm going to want to do a little sketch so I can figure out what quadrants I'm working in. If I want tangent to be negative, I'm going to want to eliminate quadrant 3 where tangent's positive and quadrant 1 where everything's positive. Let us select quadrant 2 and quadrant 4. So if I take a reference angle of pi over 3 and I rotate him into the second quadrant, that is going to be 2 pi over 3. If I rotate that reference angle of pi over 3 into the fourth quadrant, that's going to be 3 pi over 3, 4 pi over 3, 5 pi over 3. So I now have 2 pi over 3 and 5 pi over 3 in my first rotation around the unit circle. However, I've changed the interval to go all the way up to 4 pi. So that means when I get back on my rotation to 2 pi, I want to think about 2 pi with a denominator of 3. I now have 6 pi over 3. So now as I rotate around the unit circle again, I can just add those important little increments as I rotate around. Hold on, let me erase that so it's a little easier to see. Okay, so I'm back at 6 pi over 3, and now I'm going to add 2 pi over 3 for that second rotation to get to that other solution. So I've got 6 pi over 3 plus 2 pi over 3. That'll give me 8 pi over 3. And then I'm going to keep rotating until I get to the fourth quadrant. So I now have 6 pi over 3 plus 5 pi over 3. That gives me the solutions for that second rotation there, 11 pi over 3. 11 pi over 3. Okay, so now those are for u. I need to find them for x. So I'm going to take the solutions 2 pi over 3, and I'm going to set them equal to the u substitution, 2x, and cross multiply. I get 6x equals 2 pi. Yeah, he reduces to pi over 3, but like, I don't know. I'm just trying to like envision my solutions right now, so I'm not going to reduce it just yet. Going to start marking these so I like know where the answer is. The math is getting crazy. Okay. Okay, so now I'm going to list these all in order. I've got x equals. Are you ready? 2 pi over 6. 5 pi over 6. 8 pi over 6. And 11 pi over 6. Whew.